Okay, so for this problem, let me go through the problem first. It gave me a number nums, which is an integer array, and then I need to calculate the prevalent index. So what's the meaning of prevalent index here? It means that I need to find this index. The left sum equals the right sum. So it's better to explain the meaning of it by looking at an example. Let's take the first example. Let's look at the first example. So we can see that the left sum, which is nums 0, 1, 2 equals 11. And for the right sum, if the result, the prevalent index is 3, it means that the 6 is the number that index point to, and we need to look at when we look at the right sum, we need to calculate the sum of nums 4 and nums 5, which is 5 plus 6 is 11. So now we understand the input and what should I return, and in other words, the output, what is the output and what is input. And now let's look at the constraints. The length of the nums, the minimum of the length of num is 1. And here, we should also pay attention to this line of information. If the index is on the left edge of the array, it means that the left sum is 0 because there are no element to the left. This is also applied to the right edge of array. It means that, for example, if we take the index 0, for example, then the left sum will be 0. And if the equivalent index point to the 6, then the right sum will be 0. The left sum will be the sum of all the sum of all the elements from index 0 to length nums minus 2. Okay, now I clarified the problems. Now let's move on to the coding part. So for the coding part, the overall intuition is that I can apply the pre-sum strategy because it is easier for me to get a slice of the sum of the sub-arrays. Okay, so now we know what strategy is suitable for this what algorithm is suitable for these problems. Then let me move on to the coding part. For the coding part, I'm going to divide into the 4 pieces. The first piece is initialize, and then initialize the needed variables, and then I need edge pieces and the main part and return. Okay, so for the initialize part, because I need to use the pre-sum, so I need to initialize the pre-sum. The length of the pre-sum is less nums plus 1. So I would like to use the n I would like to, initialize n as the length of nums. So here, I will just use n. Okay, now I initialized, I only initialized the pre-sum, and now I need to build the pre-sum. So how can I build the pre-sum? I need to iterate through the nums, and then build the pre-sum by iterates through all the nums. So pre-sum 0 will equals 0. And then pre-sum I plus 1 will be pre-sum I and nums I. So we already have pre-sum 0. So here I'm gonna begin to build pre-sum from index 1. Okay, now I finished the initialize part for the pre-sum. Let's move on to calculate, think about our return value. So we need to, I just need to return an integer, which is the index. Okay, so now let's move on to the edge cases we should think about. So the first situation is if the index, so if the index is if the n less than 3, if n less than 3, then we have situations that the left sum, either left sum is 0 or right sum is 0. Let's handle those two edge cases first. So if the left sum is 0, it means that, for example, if n equals 2, if there are 2 elements and nums, if 2 elements and the nums 1 is 0, then we can just return nums 0. We just return 0 because the equivalent index is 0. Because if the index is 0, equivalent index 0, the left sum is 0, and the right sum will be num1, and it is also 0. And then another case is if the n equals 1, if we only have 1 element, then the left sum and the right sum all equals to the 0. So we can just return 0. So in addition to those two cases, if those two cases are not being met and the less of nums less than 3, we just need to return -1. It means that we cannot find the equivalent. And now let's jump to the key part, the main coding part for the general cases. For the general cases, so we need to calculate the left sum and the right sum and then compare if they are same or not. If same, we just return the equivalent index based on that. Okay, so let me iterate through the nums again for I in range n, and then I need to calculate the left sum based on the pre-sum. So left sum I will be the pre-sum will be the pre-sum will be the pre-sum I. Here I want to change another variable name just to make it different from the previously, I. Okay, the left sum is pre-sum J, and the right sum will be the total sum, which is the pre-sum -1. This is the total sum minus the pre-sum G plus 1 because because we will minus all the pre-sum including the pre-sum J. Okay, now as long as we have the left sum and the right sum, then we are able to make the decisions. If the pre-sum equals the right sum, then we can return return J will be the will be the equivalent. If after the for loop we didn't find the equivalent, then we just return the negative one. Okay, it is accepted. Okay, so overall for these problems, it's easy, even though it is a easy problems, it's a little bit hard to think about using the pre-sum strategy and also need to think about the multiple edge cases, need to be able to handle well. For time complexity, first let me analysis the time complexity. So you can see that I have two for loop, and within each for loop, the operation will all take like consistent time. So the time complexity will be O n, and for space complexity, because I initialized the pre-sum, so it consumes O n time complexity. And in addition to this part, we only we initialized a few variables which only take consistent space complexity. So overall, the space complexity and time complexity are all O n.